And with a little dignity left, I welcome all of you to the second part of the project When Python Meets Metal. Last time we said goodbye after retrieving data by Selenium and made some fast manipulation and then saved and load the Excel file for a preliminary visualization. Now, today we're ready for the geographical plots, and the main guest is GeoPandas. GeoPandas, as I told you before last time, it's a library used for working with geo data types and allow users to easily interact with Python libraries like pandas and Shipley. Now, as the legend says that every minute a new metal band gets born in Finland, let's get a move and start again with coding and metal. Before starting, let me show you a lifesaver for avoiding any troubles when installing both libraries and dependencies for GeoPandas. In fact, I found one only but tough problem, which is Pt.2, which may lead you to a meltdown. Now, just follow my tips. Go to run cmd and you got to install the sequence of these three commands. First of all, pip install pipwin, which is another version for pip. Then pipwin install Shipley and pyproject, which are the two main dependencies. And finally, pipwin install Pt.2. Now all the trouble should have gone, and you're ready for following my project. And now in the second part, we start by importing the main libraries. Just few ones: pandas, GeoPandas, geoplot, which is another library like GeoPandas, but will be used in a very small way, and it's a very smaller library rather than GeoPandas, but very easy to use. Import JSON because we are working on JSON files, and then the Matplotlib, Plotly Express, and Plotly Graph objects. This is important. Why I'm importing Matplotlib PyPlot? Because in the background, GeoPandas work on Matplotlib PyPlot for the static plots. While we're going to use interactive data or plots, it's just going to rely on another library, which is Folium. Even if I didn't have to import here, it's working and switching on just by using different command. Okay, so now the purpose of this part is pretty easy. I'm going to import two data frames. The first one is a geo-json file, this one, and then I'm going to explain this value. And the other one is an Excel file containing the cities. In the geo-json file, I see here multi-polygon and a series of coordinates. This are all the numbers, a list of coordinates, which means I'm going to plot a surface. A surface may be a region, or a country, or a continent, while when I got only latitude and longitude, I'm just going to plot a point in the map. And that's pretty easy to understand what we're going to do now. Once I imported these two data frames, I'm going to convert them into two GeoPandas data frame, which is essentially using a command for creating a column called geometry, like this one. Geometry is essential if you're not used to with libraries that need to display information on a map, okay? No matter if they are polygon, multi-polygon, or points, or latitude or longitude. This is a geometry, and they need this column to be plotted in GeoPandas. That's all. Once we're done, we plot this information. So let's see how to do that. Here I imported the geo-json file in reading. Just remember load, don't confuse with loads, because we converted an input, not string, an input JSON or text file, and we go in form of a dictionary, and we're gonna convert it into Python dictionary, because a Python dictionary is needed to work with the geodata frame. And now I use the command GeoPandas geodataFrame from features, so from the whole data frame, and I create this new table with the column geometry. Now, in this way, I'm ready to plot this information on a map. Same thing will be done for the Excel file. I just select only the Finnish information by using the column ISO 3. This is especially useful when you don't know which data to keep in your data frame, if you want to just keep the essential information. Once we're done, I do the same thing as before. So I create a GeoPandas geodata frame, but now I need to pay attention because now I'm using this this data frame from itself called Finland. And I'm using the command geoseries from x epsilon. So I start from in two columns, latitude and longitude from Finland, and I'm converting this to one into a geometry and a series. And this series will be used for creating a geodata frame. Don't worry if you're confused now. Just use it as an example. Just take your time. It's definitely surprisingly easy. Trust me. This one for the moment will be ignored. CRS is on the other way, and on the other hand, a pretty essential tool and input data because it's the coordinate reference system, and there are a series of them. So sometimes you make all the job properly done, but it doesn't display because you need to switch from another CRS. But for this example, it's okay. Later on, I'm going to merge some columns, so I need to rename correctly the column city with the uppercase, and that's the result. Now, from here, I got a multi-polygon as a geometry in Kuma, the regions. And here on the city, or GeoFinland, I got it as a geometry to the few points. Now I'm ready to plot them, and I'm using just the same command and matplotlib. So first of all, I just plot Kuma, so the region, and I customize the data. And I store as a variable. This is essential because, as you probably know by using pyplot, when you want to store plot two data frames inside the same plot, we need to make as a reference the axis, and we use as equal the variable of the first plot. Nothing different. CMap blues, that's all. Once I customize, I just use the same command plt show. And that's the final result. That's a static plot, okay? No information are provided when I'm hovering over them. And that's pretty easy, it works. So you see, it's not so hard. Just be precise when you use the name and the coordinates. Then I'm gonna show you for ending this part. For ending this part, I'm going to show you the way to represent the same plot here from static to a dynamic way. And for doing it, we need to switch from the background of pyplot to the background of Folium. Folium is another fantastic tool, another library which is in HTML language, and it's used to display data with the coordinates. And it's a really powerful tool, but for now on, I'm not going to confuse you. So the only difference, I just have to switch from the command plot to explore. And that's it. We're gonna do the same thing as before. Just change AX with M, because M is the command used in Folium. And that's it. The final results are much important. Tooltip is the input we need to specify if we want to choose to display the information when hovering over the part of the plots. So now, if I'm gonna hovering over the points, I'm on the table how it's called GeoFinland, if I'm not wrong, GeoFinland, this one. But if I switch here, I'm going on surface, I'm using the Kuma data frame. So we have two data frames and they're displayed correctly. And this way we can even switch here to the bar chart and the legend and see the color changing. And that's all for this part. Title for this part is pretty self-explanatory. And the point is, we need to do it very fast because you don't need to many explanations. It's pretty easy, but we need to do that. So first of all, we imported Finnish bands. Do you remember? This is the pandas data frame we created by retrieving data with Selenium, then store it in Excel file, read the Excel file and convert it into a pandas data frame. This data frame contains the name, the genre and location for the Finnish bands. I need to drop all the null value, and then I need to manipulate this data because I need to merge these data frames with the previous one of the city, or the Finnish city. So we need to work on city column having at least the same name as the column. So first of all, I split as a string the Finnish band's name because it's a mess with a slash. I created two columns, the right and the wrong one for the names. I deleted the column with the wrong one and the previous city and rename the right one with city. It's pretty easy, so don't be confused from what I did. And finally, I created this new GeoPandas data frame by merging these two one. And that's the final results. Too many unnecessary information, but better more than less. Band, genre, location, region for all the metal bands. I even have the latitude, longitude, and the geometry, much more important. And just to have more information, ISO 3. Now, this is the dirty part. I need to find all the region Finnish total name, and I want them to be as closer to the one we need to use here. Because now the new Finnish total have the name properly done, and I need that my Finnish total region are properly done. Why? Because here it seems okay, but look at here. We got a series of names which are not properly written. For instance, Osima has an empty space on the left. Another version is empty space on the left with a slash and another name. So we have early and later inside the brackets. We need to delete all this fake way to write it, okay? And for doing it, we need to import a regular expression. Personally, I don't love this library because I really suck at doing it. But we need to do that. And this is a trick you can use even for other projects. Whenever you want to clean your data frame and just delete the wrong way for substituting with a real one, instead of using re.sub, we can use this trick. Use a dictionary containing a lot of information where the key are all the patterns that you need to delete, but to recognize. And then, as a value, the right one you need to store. And this is what I've done. For instance, here, every word includes Usima, followed, if any, by the word early or later, or sometimes even the word including the word Usima plus something before, for instance, the empty space. And that's the final result. Once I've done all this pattern, I create a function that say, okay, look at the items here, so the keys and the values, and substitute the wrong one with the right one. So the Usima, Kante, Ame, and so on. And that's the final, and apply to the fin total region. Then I need to make some other cleaning by splitting another slash and keep it just the first value, and then once again for the other brackets. And that's the final result. You use a unique for testing time after time. I'm pretty satisfied, but I see, no, okay, here seems everything okay. Unfortunately, when I do print sorted, all the value and the length, I see this one. There are empty space for two regions that I did and I forgot to use in my patterns. You can do it as a homework because I'm pretty tired now. And you can use, just a tip, this pattern here, B, point, and python. So the empty space included with the name of the property region. In this case, Järvenpää e Laajavuorenki. No, Laajavuorenkuja. Not sure. Now we're ready for the next part, because now from now on we go pretty fast and we're gonna show you a slideshow of all the plots, both static and interactive, by merging or not all the information we have. Ready? Let's go. Now let's start with several tasks. I got a new GeoPandas data frame with all the regions properly written, and now I want to provide just a glance of a fast visualization of all the metal bands in Finland by cities. Okay, for doing this we just use simple commands, so explore once again. But look at here, I'm not using two data frames, but just one, fin total, so the one we already created. Why? Because there's another way to plot a surface area instead of using a Kuma, for instance, a data frame with multi-polygon or region as a geometries. and it's by using the command tiles. This is possible only if your geometry in your data frame are properly done. And you can go to the official documentation with GeoPandas and reading all the stuff. You can even provide an URL in the case, okay? These are the three specific alternatives. The last one, I tested all of them, and the last one, I think it's the coolest one, because it's metal, it's dark, and it's filling, okay? It doesn't mean much, but okay. Let's go back. Here, I didn't provide any other information apart this one tooltip. I just for sure, you can just select few information, not all the columns we have in our data frame. And as you can see, city probably it was not, band probably were not the best choice, and then you see why. Because for each city we have a lot of bands, and so it will just provide you with one in the name, just when you hover over the data. Then it folds. Okay, this is the other information, the color. This time we're not just selecting a color according to our tastes or other reasons, but I want to quantify the color according to the number of bands for each cities, and that's the result. Isn't it cool? Okay. As I told you before, if I hover over the region instead of the case of Kuma, we don't have any information. But if I go with the city, even if I lagged, I got information I provide. So just city and band. Just to make you understand, the vivid green is the most populated cities. So in this case, Helsinki. Oops, spoiler. And now let's see the same thing, but not in a GeoPandas visualization, but just in pure data analysis way. So nothing really different from what you probably used to. I use, first of all, just select and make some cleaning. Only the columns I need. I group by region, city, and then just select the band. All only unique value. I sort the values. This is strange, because even if I'm doing in a descending way, he accepted ascending equal true. Finally, I select only the top 10 popular, most popular, and then reset the index. Only difference here, instead of using plotly express as usual, I just use the alternative way, which is go using objects. So I select as a variable my plot as a go.figure. And then I update it. This is a wonderful way in the case you just want to update it time after time because you have new ideas, or maybe because some other people working with you on the same project, they say, hey, why don't you make these other things here? And so that's a pretty easy way, because you can add how many update layout you want. Thing to understand, in the case you never use a background color, discrete sequence, provide just the X and Y values, number of city, color, once again quantified by region, and that's it, nothing special here. Specify the fonts, the family, and all the information for the axis. That's the results. So a typical bar chart, okay, I specified orientation or horizontal. And let's see, as expected, Helsinki is the top, and by far the top. But then we have something like the other big four, Tampere, Oulu, Jyväskylä, Turku, and then other big five. Just a curiosity, I compare this value with those of the last year, and a couple of changes has been done, but not much. Okay, so now we can do second achievement. So let's see how the number of cities by regions this time, and we'll see in both static and interactive way. And plotting regions follow the same path we did for the cities. So we start with the usual cleaning, here are the columns, renaming, and so on. Once again, now we create our GeoPandas data frame and we merge it with Kuma. So the original data frame we have where we got the multi-polygons coordinates and region, and for this reason I rename it. It's the column we merge it. That's the results as for cities, but now we're doing something a bit different, just a few. We group by region, of course, as did before, and we select band, geometry, and geometry region. Remember, geometry is the column for the coordinates of the city, so points. And geometry region are the list of multi-polygon coordinates for the surface of the region. But now, if I just select this one, I will have some problem because I need to do something as usual. And if you not use, we can use the command aggregate, AGG. For the band, so for the first column, we use number of unique values because we're counting the number of bands for each region. That's the only real target we need. But as we select other two columns, geometry and geometry region, we need to do something, otherwise we cannot proceed. And the only thing I do is just, select the first element, the first and only elements. And that's it. In fact, if you're not doing it, just to make you sure what I mean, that's what I do. Group by the region and select the column. I print all these elements and I see for the region Kainu, I got a list of all the bands. This is the geometry as a point, so for the cities of each bands, and followed by the multi-polygon of the regions. Now, if I just say number of unique for bands, this is the results I need. But look at geometry region has some weird result because it's counting something that is not need to be counted. And for this reason, I select first. Once I'm done, I sort the values, drop the columns of geometry because I got to make some rename, and finally I got my plots. Only 3 columns. And once again, I created my GeoPandas. And now pay attention. Do you remember, if I say Kuma Explore, it just plot the right data because they're stored in the column multi-polygon called geometry. But now I changed the name, and for this reason I did, because I'm going to show you how to do that. Just select the column geometry region and it's done. Once again, you link the 2 columns and plot the results. That's the interactive way. If I go here, I see for the Lapland there are 88 bands, and that's in fact the least common result. The yellow one means the most popular, and so the region of Uzima, more than almost 1300 results. And we can explore the static version just by saying geometry, Kuma region, geometry region plot. Once again, we store in the same axis, and that's the results. Once again, the color, the vivid green here, is the same as for the yellow and interactive one. Now, the project itself ends here, but I was curious and I tried to replicate the same result in Plotly because I love that libraries. It's my favorite one. And first of all, because I wanted to understand if I can use geodatas even with Plotly. I knew I could, but I never done it. So I was curious and I tried. Please pay attention and follow what I'm showing you now, because it's not so easy. We all use the corepleth function. It's one of the best one. Unfortunately, it's not so easy when it comes to work with the geo-json files. First of all, I converted my GeoPandas data frame into geo-json file with 2 files and then driver geo-json. I reopen it and I load it in a Python file. That's the final result of Finland geo-json. It seems apparently it looks like the same JSON files before C, but pay attention now because the geometry is very important and there's a structure here that need to be paid attention about. Why? That's the reason. Why we use Plotly Express corepleth, we select first of all our data frame, and our data frame must be the GeoPandas data frame, so count geo. But now we need geo-json data. And for this reason, I select my file, which is the name of my geo-json file. And, my geo-json file converted into Python file. Now, these are important input data to pay attention. Locations and feature ID key, because they are connected each other. Sometimes it's not enough to say locations and regions, and that's all. region, it's one of the column names, so I just select the string name, and that's okay, it works properly. Unfortunately, we need to associate this name for each region to a series of values which are the multi-polygons coordinates, and these multi-polygon coordinates are this one in Finland geo-json. And for associate the name of, for instance, Uzima to the coordinates I found here on Uzima, I say future identity key and the path who leads me to that name. So properties.region. You can find here properties.region, and you find the value Uzima. Of course, you find the name of all the other regions. Now, scope is a pre-built function, so no pay much attention. The only real difference here to pay attention is the feature object update geos. You're used to update layout, but not this one, because you never use probably geodata or GeoJSON data on Plotly. In this case, I suggest you to use fit bounds because it may allows you to represent properly. For instance, this is the final results, okay? It's interactive, region LAPI band 88, so the values are correct. But for instance, if I don't write fit bounds here, I keep it on. Okay, you find something that you got to... so, okay, nothing essential, but it's much better if you do it. For instance, let's see, for instance, if I don't insert some of these values, for instance, this one, feature identity key. Nothing is explained, because it doesn't find a way to connect this region with a value. So, in the future, if you're interested to work with the geodata, and you're interested in working with Plotly, because Plotly is definitely one of the best way to work on plots of geographical plots, pay attention to this one. You will find a series of problems. Starts from these inputs data that I show you here. Okay, that's all. The project ends here. And we are at the end of this 2-video series for When Python Meets Metal. I hope you enjoyed this as I did in the making of it. Now, regardless you're a metaller or not, and you will be subscriber or not, I will enjoy if you leave your comments and share your ideas for the future of this channel. The point is, I'm running out of ideas because I don't know which path to follow from now on. If you want to get in deep of some commands or libraries, please let me know in the section of comments. Otherwise, if you want to find something else or you're intrigued by some other ideas, please, once again, let me know. For now, I don't have anything to add. I thank all of you for the patience you showed in the meantime, and I greet all of you. Let's see in the future. I don't know when. Okay, bye bye.